for this question, what's happening is that for each bag you have 10 blue, 10 white, 20 red, and the question is asking what's the probability of getting 3 blue candies if you drew 5 times? That's basically what it is, right? So what you want to think about is a series of questions. So first is what is the probability P for getting a blue candy? What is it?
0.25.
Yeah, it's 0.25 or 1/4 because it's 10, 10, 20, and 10 of them are blue. So it's 10 out of 40. So you know that P is equal to 1/4 or 0.25. And then if you read the question carefully, what it means is that you have 1/4 chance of getting a blue candy from the first bag, also from the second bag, from the third, from the fourth, from the fifth, right? So in some cases, if you do that, you might end up with all 5 blue candies, which is very rare. Or you could also have something like 2 blue candies and some other candies. So now the question is, what's the probability that you can have 3 blue and the rest 2 of something else? Okay? So that's the question. All right, so if you have a bunch of possibilities. You might have blue here, blue here, blue here, but the other ones are not blue. The probability of not getting a blue will be 3/4, right? Because this is 1 minus 3/4. So that's one possibility. Where 3/4 is what we call Q. Q is 1 minus P, which is 1 minus 1/4, which is 3/4. And it could also be that the blues can be from the first 2 and then this one, right? Or it could be first 2 and then this one. So you have many different ways that you can have a blue. Right? So think about like counting all possibilities. You might have like blue, 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 and not blue. I'll put not blue as N. It could be like blue, blue, not blue, and then blue, and then N. And blue, 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 not blue, not blue, but then blue. And then you can now go to blue, not blue, 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 not. You can keep going on, right? So now the question is, how many different ways can you arrange 3 blues and 2 non-blues? Can you think about that? How many ways can you arrange 3 blues and 2 non-blues? Yes?
Wouldn't you like do like 5 factorial divided by 3 factorial?
That's exactly right. So you do 5 factorial because you have 5 items. So to permute those, you need to think about 5 factorial. Right? However, there are 3 identical ones, right? So permutation of these don't get distinguished. Okay? So if it's like B1, B2, B3, you can shuffle these 3 around, and it's still the same thing. So you have to delete that 3 factorial because 3 of them don't get distinguished. But also n and n are treated as same, so we don't distinguish them. So that's what we get, right? And this is what is it? 5 times 4 divided by 5, 4. So that will be 10. You can use a calculator to calculate this by using 5, choose 3. Okay.
Can you explain the 3 and 2
You have 3 of the identical ones, 2 of the identical ones you put divided. Okay. All right. So you do this with a calculator, you can get the same value, 10. And this is where the binomial formula comes up. See, if you think about the probability that exactly this would happen, or this would happen, this would happen, they're all products of 1/4, 3 times, and 3/4 twice. So what you end up with is you always have 1/4, 3 times. When you list all of them, all of these possibilities have the probability that 1/4 to the third power and 3/4 to the second power. But because there are 10 of them, you put 10 here, and that's the answer. Okay? In fact, I would just accept this one, because for this one, it kind of shows exactly that you understand what's going on. Okay? Yeah. But another way to do this would be just to use in your calculator binomial PDF, where the number of trials is 5, okay, and the probability is 0.25, and what you're trying to look at is what's the probability that you get 3 of this instance occurring. Okay? So that's another value. That's how you do this. And I think that if you do this, you get 8.79%.